So in this example, the first example, we have a heterolytic right here, similar to this, where Z, in this case, Z is bromine. So we're going to say Z is, in this case, bromine. And bromine is more electronegative than C. So we're going to apply on this example a heterolytic bond cleavage. All right, so you're concerned between this carbon and this bromine, this pair between them. Once again, more electronegative. That's where the arrow goes toward. What charge would be on C if the electrons went away from it? That would be a positive. So what is this? A carbocation or a carbanion? If you said carbocation, you are correct. Yes, it's a positive, it's a cation. And of course, bromine right here has a negative charge. Very well. So this is a carbocation. And this would be a tert-butyl carbocation because we have a tert-butyl group, if you can see it. Now let's do a radical reaction on this one. So this splits evenly between them. Here's one electron, one unpaired electron, and here's another one. Very well. So this would be obviously your electrophile. If we go back, this could be a nucleophile. And these are just radical intermediates. Very good. So now let's go to the next process, which is bond making. It's equally important. It's as important as bond breaking because they both occur. You can't have, if you think about it, you can't have a bond breaking without a bond making as well. So let's pay attention to this. So you have radicals that react by donating single electrons, whereas compounds with unpaired electrons react by donating or accepting a pair of electrons. So they should be very, very clear that this one can only give up or donate to form a bond one electron, but this one can do two. So it can donate or, of course, accept a pair of electrons. If you understand what we did before, you should be able to understand this because this is basically the other side of the flip side of the coin. So let's pay attention. So imagine I have HBr right here. And I'm going to put the electrons on HBr. We're going to do it so you can see exactly. The way this reaction is going to proceed is this way. Carbon is interested in forming a bond with hydrogen. This electron, if it shifts to the hydrogen, is not going to create a bond. It's only going to, this is only one electron. So this is what has to happen. So you would, again, split this in half. But now, instead of just taking this, putting it on H, we actually form a bond between the H and the C. If you notice, this is taking an electron away or with it. And it would form something like this. Let's show you the product. Okay, we need a little bit more space here. Watch. Hopefully you can make sense of this. Plus, okay, let me use actually the same color so we can keep it consistent. So here's H. I'm going to put the electrons here for a minute so you can see them, and then mark them here as well. So here's that blue one, and here's that black one for the carbon. Hopefully, again, you can make sense of these electrons. So this is bond making in the radical reaction. So in this case, the radical donates one electron. Now let's do the second one. Imagine we also use HBr. Now, there's no need to take an electron from this bond right here between H and Br because we have a pair of electrons ready to form a bond. So what would happen is the following. So here, by donating a pair of electrons. So look what happens. This means a bond is forming between the H and the C. Now, of course, this bond has to break. And you can, by the way, you can put them also below as well. So it doesn't really matter. So this would be the product. Right here. So what happened here is that the carbanion donates a pair of electrons. The carbanion donates a pair of electrons. And then finally, in the last step, or in the last example, let's say we have now a bromine ion. This is electron deficient. This is electron rich, electron poor, electron rich, nucleophile for the bromine, electrophile for the carbocation. So what would happen is one of those pairs would move and form a bond between carbon and the bromine. So you would get a product like this. Now, of course, they don't have to be in different colors, those atoms, just letting you know. And we don't show usually the pairs, but for this case, we will, just to show you exactly what happened. And of course, in this example, the carbocation accepts a pair of electrons. So you should think about these along acids, bases in terms of Lewis acids and bases. So the bromine here is a Lewis base. The carbocation is a Lewis acid, which remember translate into electrophiles and nucleophiles. So keep that in mind as we go through. Again, as we did in the first one, try to actually do these. So this is an example where you have the cation and the electrophile and the nucleophile, and then here you have two radicals. See if you can form a bond between them, and then we'll check in the next video.